Well, good morning, everybody. All right, so I'm a little later than I normally like to be getting you a forecast video in the morning, but that was because yesterday I was in the Imperial Valley in California, which is right in here. So if we zoom out just a little bit, sorry about that, you can see California's Central Valley here. Here's the Mojave Desert, and you're getting down here near San Diego. So when we flew in day before, this drive between San Diego and Imperial Valley is very interesting. You're going over some just completely exposed rock with almost no vegetation in it. You're going from a marine stratocumulus covered area right up against the ocean where the temperatures are routinely in the 70s to a place where the temperatures are routinely well over 100 degrees Fahrenheit, just in a short 2-hour drive. When I got here, I got a text from my uncle who lives in west central Illinois, and he showed me that his rain gauge had over 4.5 inches of rain. And when I was talking to the growers yesterday in this area, it's incredibly agriculturally productive region right in through here. It was a reminder that my uncle received in the span of 24 hours 2 years worth of rainfall for this area. This area is supplied with its water from the Colorado River. It's incredibly important to California and U.S. agriculture. And it was just, it was an incredible trip. Now, when I drove back to San Diego to catch a flight home last night, I got home very, very late because as we were flying home, as you can imagine, the flight back to Chicago, which is the airport I flew into, went right over the top of the Southern Plains. And I will never forget, the pilot said something I don't usually hear this kind of tone with. And he told, as we were flying right over this part of Texas, he basically told the flight attendants, you have 2 minutes to get into your jump seats and buckle up. And then immediately the seatbelt light comes on, and he just tells the rest of us to please buckle up. Now, as I'm flying over parts of Texas, what we were flying over were some storms like this one. Now, this is the radar out of Lubbock. And yesterday, I don't know if you follow any storm chasers, but many of them were on this particular supercell. There was a lot more. I'll show you all of them in just a few moments. But some of these were incredibly potent and large storms. And he had to divert path. We had to go around all of this. And I was really kind of mad because as you watch this animation, I was sitting in an aisle seat. And the pilot even said, hey, if you look out your window on the right-hand side of the plane, which would have been to the south, you can see the thunderstorms we're going to go around. And the guy next to me was sitting in that window seat. There was no one in between us. And he totally didn't care. And I'm like, dude, open the window. I want to see these thunderstorms. But he had his earphones on and he was watching The Matrix. We've all seen it. You can watch the storms. I should have gotten a window seat. I don't know what I was thinking. But this was one of the big ones. Now, some neat things to think about with this radar. There's so much going on here. These are wind farms. Okay, so you can see the radar beam is intercepting the blades of the wind farm. This is a large one north of Petersburg. That's actually kind of a famous wind farm there because back in 2018 in June, a big squall line hit it, and the wind farm actually altered the speed of the storm. That's a really interesting case study. See all the stuff out here, this clear air echo? That's actually the feed going into these storms. That's moisture in the atmosphere. You can see it all rolled up in these individual streets of moisture, and there's actually some little puffy cumulus in this. Remember, the radar doesn't see clouds, it sees rain. And then we watch that storm right there. Now, there's a special radar that was out scanning the storm called Rainfall. It's a new design on radar. Actually, it's been around for a while, but out in the field, deployed in the field, it can measure some pretty impressive things. And this guy produced an absolute monster of a tornado. We call it a wedge. A wedge is where your tornado, the visible part of it, is wider than it is tall. Remember how Matt taught you a little while ago about the three-body scattering? So can you see right in through here these echoes that are coming out of the back? Well, that's the hail core from this storm, and it eventually became all wrapped up in rain. But many, many people got incredible video and pictures of this one. It was nasty. But as it went through, it did bring in rain to this part of Texas, which does need it. I had looked up, and for Lubbock, if you look at their evaporative rate, they're about 10 inches off, right? So their precipitation minus evaporation is minus 10 inches. So they needed every bit of rain that was coming through to this. So let's go and have a look at what that looked like overall. And here's just a good example of the last 72 hours of total accumulated precip. And the story just continues as to where these biggest storms continue to lay down their precipitation. And Texas wasn't the only show in town. If you just take a look at the radar data across the country, we had storms all over the place. From the Central Plains, they started off down here in the southeast, just erupting in this area. Watch at the beginning. See all these here? We had storms in the eastern Cornbelt, storms in the western Cornbelt, which is critical because this area is about to go over quite dry. And as I mentioned, some of these were pretty nasty. If we look at, they just updated it. Hopefully they'll give me the data from yesterday. There we go. 26 reports of tornadoes, but that little right there, that storm right in through there was the one that was kind of nastiest as it rolled through. Now I want to show it to you on satellite. This is what we were flying over. So as I left right about here, okay, our flight was going in this direction, and we had to go around all of that deep convection you see here in the southern plains. You can very easily tell that the dry line had backed up way into New Mexico and Colorado, just because of where the storms initiated. But before I just take one more quick look at those, take a look at what's going on over the southeast as well. More very intense thunderstorms, locally very heavy rainfall, and we need this in Florida given how hot and dry it's been. Okay, still some wildfire smoke in the atmosphere. Some of it's actually getting down pretty low. My drive home from O'Hare back to where I live here outside of Champaign, the air quality was quite bad last night behind all of this. But I do want to show you one last time what those storms look like. So this is this morning. Okay, let me take you back to last night. Now, as these storms erupted, that's the one we're watching right there. On the back side, we had the outflow generating dust storms. It's an amazing thing that happens in this part of the world where the outflow can just pick up all that dust on the backside. But these are deep. All these ripples represent gravity waves in the upper atmosphere induced by the updraft of these storms. Okay, they were hailers. This is just looking back at the last, 24 hours of hail reports. So from parts of, sections of Kansas and Colorado, but through a lot of Oklahoma and Texas, these were just dropping a lot of hail. And I've shown you multiple times we're way above average on wind and tornado reports, and we're, are above average on hail too. Okay, all that being said, it gets us back to a narrative, right? And if you look back over the last 2 weeks, we have soaked once again this same region. And I'm soaked is not the right word. I mean, some of this rainfall has been just torrential at times, and it's been incredibly disruptive. On top of that, throughout the southeast, we've been extremely wet. We had desperately needed rains getting through parts of Nebraska, and multiple chances of getting this rain through parts of Iowa, Illinois, Wisconsin, Indiana. In fact, we had a bunch of severe weather earlier this week in this area too, strong winds with those storms that came through. Now, I think about all of that, and I just want to put it in the context of the last 2 weeks, in the context of history here. So the percentage of normal precipitation, and what I'm looking for on this are some places that didn't get that rain. Now, remember, for some reason on the AHPS product, we've lost parts of Nevada and California in the data. We do have it in the Northwest, which has been very, very dry, and it's about to get extremely hot in the Northwest. But just have a look here at, bunch of the northern plains, the whole region quite dry. Sections of Iowa dry. This part of Indiana and Ohio in the last 2 weeks has been drier, although they're still very delayed in the eastern Corn Belt, especially Ohio, with getting a crop established. Same thing for the Northeast. Now I look at all of that. I'm just trying to assess where this might be going here in the near term, and I want to tell you kind of what I'm looking at in terms of what could be the most important feature going forward. So since the last 2 weeks, we've had a trough around Alaska. The jets run up here. That's been the larger ridge that's been in and around, parts of Manitoba, even Saskatchewan, over parts of Ontario. It's now, on average, been sitting more over the Hudson, here. That's what's been creating all the wildfires in this area. But we've had a lot of high pressure there too. But we've had this area of lower pressure through here, which has created slow-moving storms, a lot of colder weather at times into the Northeast. And that's it. That's the pattern. This is what we have been paying so close attention to. And it still looks like this today. Okay. So listen, I'm going to take you on a bit of a forecast journey here all the way out through summer with the new European model. That's where we're going to land at the end of this video. I'm going to tell you the most important things to watch this time of year. In summer, okay, we tend to lose our big teleconnections. I'm talking about big sweeping MJO movements. I know we have one right now, but I'm talking about in summer. You lose the jet stream flow. So what you're always looking for are the position of these big subtropical highs. That is the Pacific high. Okay, that's where it is right now. And the Bermuda high is kind of in multiple places here. There's just this broad area of higher pressure. So you can see there's high pressure here, there's high pressure to the south there. This is all, the extension of the Bermuda high. And what I want to make a case in point for is that if that Bermuda high, okay, which generally lives, I could actually draw this all the way over to the Azores. If it lives within this area, okay, just meanders back and forth, we will continue to be able to tap into Gulf moisture, all right? And tapping into that keeps this region, and probably extend that into the northeast, with available moisture for thunderstorm activity. And if the Pacific high squeezes into the northwest, you'll end up getting flow over the top, which will really make a lot of storms in the midsection of the country to get all the way to the southeast. Now, later this summer, or once summer actually begins, okay, we have to watch out for if either the Pacific high or the Bermuda high, which is somewhere in there, if they drift. Okay, they can drift as the momentum of the atmosphere changes, and that is the narrative I want to craft for you later on when we talk about summer. All right. So right now, again, we've got storms rolling through the country. This is just Blitzertongue's main website. Love this website. Active storms, big squall line moving through parts of Missouri, Arkansas, and parts of Oklahoma. We have more storms out ahead of it, as you can see here. And we're going to watch where these are going, because today's Storm Prediction Center forecast has got, once again, with the dry line backed up so far to the west, we've got enhanced risk in those same areas, but it elongates and stretches clear over to parts of the Mid-South and into the southeast, with the risk of severe storms here as well. Tomorrow, Saturday, again, it's that large region that has just ample amounts of soil moisture, ample amounts of Gulf moisture, and a trigger. There's a frontal boundary, that's just living in that area because of a deeper low that's here. And then this gets us into Sunday. And once again, we're going to watch that same part of Texas just be under the gun for the risk of more severe storms. Now, the thing I want to show you is that over the next 7 days, we are looking at very, very heavy rainfall, through this corridor. But there's an area over which we have to be paying close attention. And it's this region right in through here. Notice that to the north of it, Red River Valley, getting into northern Minnesota, this part of Ontario, and back into Manitoba, we're seeing better chances of storms. To the south of it, any rain at times is going to cause flooding in this area. And I want to show you this map from a different model. Let's go to the European model. And now what we're looking at here is just the 10-day precipitation anomaly. And we know the temperatures are going to start to go up here. But as you can see, there's a region that's going to be missing out of this east of the Rockies. Now, we do expect, much of the west to be on a drier pattern at this time of year. That's more common. But to the south of that, very heavy rainfall at times. There's another drier pocket that's showing up over the next 10 days here as well. But we can see this, and it's also actually extending into parts of this section of Ontario too. Pockets of dryness are showing up in parts of Saskatchewan, the Canadian Prairie. But a lot of focus has been just thinking about this, because it's not just showing up in the ECMWF operational runs. We're seeing it in the artificial intelligence. See this again? We're seeing this in the 14-day outlook from the GEFS. That's the Global Forecasting System. The E stands for ensemble. It's a 31-member ensemble. So extremely wet here. Very, very dry there. And we're also seeing this in the European ensemble. Again, wetter and drier. And we just need to consider what this might mean going forward to U.S. agriculture, knowing that back into April and for the parts of May, we were extremely dry in this area, and we're going back over to that pattern. Now, to the south, we just can't seem to shut this down. It's just been so wet. And we are watching a pair of tropical systems when we develop off the west coast of Mexico, but they're not really showing up too well in the longer range projections to make much of a conversation about. So from here, where we're going to go is this. Over the next 15 days, I see a lot of ridging across the northern hemisphere. There's one, you can see two here. There's three, big one over this part of Europe, 4, and there's 5. And then we can maybe say that this is an extension of 1. But there's a lot of circumglobal ridging that's going on across the northern hemisphere. We've been dominated by a positional change in the trough that's over Greenland and parts of the Canadian archipelago lately. This has really given us an interesting signal in the Arctic Oscillation for this time of year. But there are questions as to how these troughs and ridges are going to be moving. And are we in a bit more of a static, almost retrograding type pattern at some point beyond the middle of this month? So with all that being said, can I show it to you? Watch the ridge build into the west while this broader trough sweeps through the Midwest here. This is Saturday into Sunday, and that's going to just pour on the heat, while this downstream trough just dips in over parts of Wisconsin, Michigan, Ontario, keeping things cool. Now, this is next Tuesday, and as we get out to next Tuesday, the models are kind of guiding us toward a late week next week, western U.S. trough pattern. They've been doing it all week long in their forecasts, and this is opening up to a bit more of a longer wave pattern. Now, because of the way that planetary vorticity is advected or moved when the pattern lengthens, these waves tend to appear stationary or even retrograde to the west, which means we're going to leave one around here for a while. And it's going to arrive, again, midweek next week and stick around. And we can see that in all of the models, there's some sort of ridging of in here while there's a trough off the northwest coast. So expect the temperatures, which are extremely hot this weekend, to rapidly change by the time we get to the middle and end of next week. And that's here. And you're going to get the inverse of that there. So with all that being said, here's where we land. Okay, this morning, severe thunderstorms, flood watches are out here, air quality issues around it, some dense fog in places. We're wet in the northeast, pockets of the northeast as well. We know that our high-resolution modeling, like the HRRR, just watch the storms explode this afternoon. This is 2, 3, 4 o'clock this afternoon. So watching the northeast, watching a complex of wetter weather move out of parts of Missouri to Illinois, which again, St. Louis took a hit with another tornado earlier in the week. That's been a kind of an epicenter of bad weather as of late. And then we watch this evening as off the dry line, more large storms jump here. Intense, some of these are going to put down some very large hail. And there's already been, I showed you earlier, some huge hail that's been reported in these areas lately. So we're just going to continue to see that. Then we get into the Saturday. This plays through Saturday, and we're watching, once again, heavy rain move through Oklahoma, Missouri, Arkansas. They extend over into parts of the Appalachian Mountains and into the northeast. As we stretch it out even longer, though, and look at the comparison between the GFS and the European model, you're going to see a lot of green, and it might obscure where the holes really are. So this is through Friday into Saturday and Sunday. We have another low. Look at it coming through parts of the Ohio and Mississippi, mid-Mississippi Valley. There's a deeper low deep here over where the fires were in this part of Canada. We need every bit of rain out of this that we can get to continue to put those fires out. And then as we work into the weekend, where does that low go, right? Here's Sunday. Getting into Monday, it just dips over the Great Lakes. So what does it do? As this low keeps moving in this direction, the old one trying to exit, there's just a boundary. And it's in both models. It just sits there. There's that other low. And it's on that boundary that we continue to pour Gulf moisture. So into Tuesday, Wednesday, Thursday of next week, which is what I'm playing, you're going to just see thunderstorms down here pretty consistently in the models. But there seems to be this corridor through which we're not getting much of that moisture. And as a result, we're looking at those drier conditions right in through here. Maybe parts of I-80 are really going to be in the epicenter of that right into the middle part of the country. So as you look out there, this goes all the way to next Friday. The probability of staying under a ½ inch is pretty high through here. More wetter north of it, much wetter south of it, very dry and hot in the west. And if you look who's going to be wetter in this pattern, this is just over the next 7 or 8 days, probability of getting an inch is extremely high into this area. But we have these drier pockets. There's one, and there's another. If you want to see who's really got heavy amounts of precip coming, it's, again, Oklahoma storms just rolled through there now, Missouri, Texas, Louisiana, this whole of the south. If I take you out to 10 days, that's what it looks like. So can you see that right in through here, there's this pocket that's going to have lower probabilities of getting good, meaningful rains in. And we can take heat and we can take some of this dryness in June, but boy, that has to break by the time we get to the end of the month. So we're going to talk about that in a second. Temperature-wise, here's today's highs, so you can just see that we're suppressed with cloud cover and also storms, but watch the northwest as I go into tomorrow. Deep into the 90s on Sunday, well over 100 in many places. Where I was, they're expecting down here to be 115 this weekend. My goodness, the heat was unbelievable. I went and got Chili's when I got in. I had to work on what was that, Wednesday night, and walking to the Chili's, which was, barely a ½ mile in 97-degree heat, was disgusting. I'm just not used to it. Then we see that this is Tuesday and Wednesday. Watch the west change. See how cooler weather coming in? We're building in more warm temperatures here. This is all cloud cover and rainfall. That's why you see it cooler to the south. So let's walk the next 5 days into the next 10. Watch the west. Ready? This is June 16th. This is the ridge opening in the middle part of the country. See the warmth returning? So this is what the concern will be. We do need heat on the crop, but we'll get to a point where there'll be too much prolonged heat that is going to be reducing or increasing our evaporation rates, reducing soil moisture. And that's that little corridor in through there that's not expected to see much precip. Now, in the near term, I'm not worried about it, but it's if it lasts that we start to get concerned, okay? So seeing all of that, let's just get into a couple of important things we've been monitoring. In the last week, as that ridge is built in, this is critical. A lot of warm water has moved into the Gulf of Alaska. Now, if that warm water stays there over the coming weeks, the narrative will be that there will likely be a big Pacific ridge setting up in this pattern. Even though the models aren't calling for it right now, that's what typically happens as that water gets warmer. Matt did an excellent job talking with you about what these MJO movements look like and why they're important. So you've seen him discuss that. So if you don't mind, I want to take the narrative somewhere else. And the thing that I want to be thinking about right now is this. Since April 1, this is what the pressure patterns have done. And our Bermuda high has been here. And our Pacific highs come in two pieces. There's been one there, and there's another one just almost off the map. We've also had much higher pressure here, which is what's created the wildfire situation. And to the north of it, that's been our, basically where the polar jet stream has been living. Now, the Bermuda high's proximity to the U.S. has continually opened the Gulf. It also made parts of Florida very, very dry in spring, okay? Now, the narrative, the thing that we have to think about is simply this. I'm going to focus right here where I just told you that dry weather is going to be, okay? When you look back historically at central United States, the worst yielding years where it got very hot and very, very dry in July, I went and found where the Bermuda high was and made a map for you, okay? And the Bermuda high is in the black H's. And you can see, I labeled the year so you can get an idea. It drifts off to the North Atlantic. And so therefore it takes the flow, which goes around it like this, and pushes it into like Nova Scotia, not into the Gulf. And in its wake, when that occurs, you just develop weak flow and higher pressure here, which is what sends these years, which are historic in terms of their impacts, into very hot and dry summers. So knowing that, and knowing that the Pacific high just randomly distributes itself during these key years as well, doesn't stay tucked up against the West Coast, knowing that means that we need to understand what's the opposite, okay? The opposite is this. In these best yielding years, the Bermuda high tucks itself up against the east coast of the United States. And the flow goes around it like that. And also during those years, the Pacific high tends to concentrate in the northwest, meaning it stays extremely hot in the northwest. And as that occurs, the flow goes over the ridge, comes out of the northwest, and meets Gulf moisture. And this is why northwest thunderstorms are a summer dominant feature. And they follow those lines going like this. So we are at a moment now where we're going to watch as all of the other teleconnections begin to lose their significance. We're going to watch to see if just these big subtropical highs, the Pacific and the Bermuda high, drift. Now, I'm going to show you some model solutions of this. And over the next week, the Bermuda high, it's here, but see this extension of it? This is not temperature, this is pressure, much higher than normal pressure. And the Pacific high is there and there. But according to the European model, the newest update, as we work our way toward the middle of June, look at that flex in there. That's why these next 2 weeks are so wet here. Unfettered access to the Bermuda high, okay? But after the next 2 weeks, watch this. Okay, here we are, week 3. That is interesting. And the Pacific high is here. Right now, it was there. Okay? Are these separating? Are they moving away from North America? I want to know the answer to that. Now you're going, well, what's all this? I mean, is it going to be cool? No. This is kind of a reflection of a heat low, where the pressure's dropping because it's actually quite hot in that area. But that Bermuda high has got me wondering, because at the end of June, getting into July, look where the highest anomalies are. And those anomalies pushing here are worrisome. Now you're going, oh crap, Eric, you just said that when it does that, we're in trouble. No. This model is not our best perform. None of them have been performing well. So I'm going to draw that so that you remember. Okay. But I want to show you how the model's consistent with itself. Because as the Bermuda high leaves, where's the best flow going to be? It's going to be like that, leaving an area here a bit drier. So if you go look at the precipitation pattern on the 30 days ending, let's just take it out there to mid-July, I don't know, July 12th. See how wet we are here, and the model has gone over drier once again? Now, could we get stormy in the prairie? That'll be interesting. That's what tends to happen if you build a ridge here. I mean, if it gets hot and dry in the middle part of the country, ridge riding storms go all over the top. They happen all into the southeast, and guess what? The monsoon gets going early if you plant high pressure right there. So lots of ridge running storms as we get into the late June, early July timeframe. Sorry, but that's what it looks like. So the other thing that we need to think about here is that this is the weeklies. This is a product from from the European Center for Medium Range Weather Forecasting, and we now have their new seasonal, which looks out monthly. And in June, this is pressure again, into July. What's interesting is we see higher than average pressure here and higher than average pressure kind of there and here. And then to get into August, and again, what is going on with the Pacific High? It's much weaker. We see more high pressure compared to average, maybe there. And the Bermuda high seems to be, something here. It's not, the model's not yet given us this clue that it's going to drift off to Iceland, which would be disastrous. But they're not in the right positions overall. And so what we can do is we can say, well, what does this mean for the seasonal QPF, or quantitative precipitation forecast? And I'm going to give it to you globally so you can see this. What this is doing, as La Nina fades, the PMM stays cool. What we see here is there's a larger area in the model that's showing drier. We see the southeast wetter. We see the North China Plain wetter. We see India with an active early monsoon, but we see the Black Sea region drier. In the European model for summer, July, August, and September, which is the newest update, is still quite aggressive, and it's showing hints of having some issues with precipitation in the center parts of two main grain belts, here and here. Now remember, when it came to the spring weather forecast, it was the European model that did the best, although we gave it a grade, right, of not very high. So I'm going to tell you this. What creates big drifting high pressure cells? Okay, what makes that happen? It's all about the full momentum of the atmosphere. And I'm sorry I'm harping on this so much, but this is key. When the momentum dies, like it did here, the only thing that brought in the wet weather to North America were the cutoff lows. Remember, we talked about that. If we get a reflection of this happening again there, then that European model's right. And you'll see the global momentum just plummet, and it'll do so at a time that will make this risk of places that are getting kind of hotter and drier. Where did I put those maps? This one's a good one to look at. It'll get this area drier and drier, and this will get steamy and hot first, and then start to back off. Those are a lot of ifs. And no, I don't have a solid solution. So even though I paint a picture of risk, you need to understand that there are many, many things that must happen in order for this to take place. And the thing we cannot forget is that lately we've pumped a lot of water into this. So it's going to take some time in order for this drought scenario to build, if it builds. But I can't argue with the European model's solution, because it does make sense if the high pressure cells drift off. The subtropical highs that anchor against North America move. So let's watch it together. That's what our assignment is going to be, okay? Hey, thanks for hanging in there. This is a long video, but I enjoyed talking to you. Thanks for kind of the patience with our flip-flopping schedules this week. You know my assignment for the weekend. I'm just going to be staring at this. We'll figure out where it is next Monday. I'll talk to you then. Thanks.